Hi everyone, so in this video I'm going to go over the 3 bonus quiz questions. So the first one says, when 101.3 grams of fictional compound X is added to water to make 506.1 grams of solution, the temperature increases from 21.78 degrees C to 91.10 degrees C. What is the heat of solution for compound X given the molar mass of compound X is 59.32 grams per mole? And then it tells us the specific heat capacity of the solution. So in this case, we want to find the heat capacity of the solution in kilojoules per mole. So in order to do that, we need to do quite a lot of work. This is quite a long question. So first of all, we need to realize that delta H of the solution equals m, the mass, times C sub s, the specific heat capacity, times delta T, the change in temperature. We know the mass of the solution. We also know the specific heat capacity of the solution, and we can find the change in temperature. I should have put a negative there, okay? Also, we need to know if the delta H of the solution is negative or positive. Well, in this case, it went from 21 degrees to 91 degrees. That means that when this dissolved, it was exothermic. It gave off heat energy and the temperature increased. So the delta H of the solution should be negative. You can do that by this negative sign, or you can also just realize that whenever the temperature increases, it's negative. Whenever the temperature decreases, the delta H of the solution is positive because it's sucking heat out of the solution, so the solution becomes colder. Well, now we need to solve this thing. So the next thing we need to do is we need to find delta T, which is TF minus TI. In this particular example, our final temperature is 91.10 degrees C. Our initial temperature is 21.78 degrees C. And when we find the difference in temperature, the delta T, we find that it's 69.32 degrees C. Now we can find delta H of the solution. So the delta H of the solution is equal to negative the mass, which is 506.1 grams, the mass of the solution, times the specific heat capacity of the solution, 4.18 joules per gram degrees C, times the change in temperature that we just found, 69.32 degrees C. And when we do all that math, we find that the delta H of the solution is equal to negative 146,646 joules. Or, we can write this in kilojoules, divided by 1,000, negative 146.646 kilojoules. But the question asks us for the heat capacity in kilojoules per mole. This is kilojoules per 101.3 grams, if you will, or just simply kilojoules. So to make this kilojoules per mole, we need to divide by the moles of the solute, in this case, compound X. Well, we need to find the moles of X that we had in the solution. Well, if we had 101.3 grams of X, and we know the molar mass of X, we can put the molar mass on the bottom, 59.32 grams of X per 1 mole of X. And when we do that math, we find that there's 1.708 moles of X compound in the solution. Now we just need kilojoules per mole. Take the kilojoules, negative 146.646, divided by the moles, 1.708 moles. So this is kilojoules. And when you do that math, you get negative 85.87 kilojoules per mole. Now, a couple things to point out. One, you can make an argument that this should only be 3 sig figs, because this is 3 sig figs, and here we have 4. The other thing is, you'll notice they don't come out exactly the same, okay? They're very close, but they're not exactly the same number, and that's just due to rounding, all right? We're just rounding differences in the calculations. So this is how we could find the heat of solution in terms of kilojoules per mole. A really important thing to remember here is that if the temperature increases, this is negative. If the temperature decreases, it's positive. So when you get a different question with different numbers, the negative and the positive answers might both be there. Make sure you choose the right one. If it heats up, it's negative. If it cools down, it's positive.